Okay, so we're looking at the notes for section 1.3, number 3. Our learning target is that we need to be able to evaluate limits analytically. So we are talking about the 3 different ways there are to evaluate limits. One way is numerically. We can do this with a chart. That was the way you just did it on your homework. Or by simply plugging in the C value. Remember, if the result is a constant divided by 0, then that means the limit does not exist. So if we get 5 divided by 0, 10 divided by 0, that means the limit does not exist. However, if the result is 0 over 0, we have to do more work to find the limit. The more work we might have to do is an analytical method, which means we're going to use algebra, or we might use some special trig limits that we're going to learn about here in a minute. Or we may want to do the problem graphically. By looking at the graph, sometimes we can tell what the limit is. So these are some examples of some analytic methods. So it says write a simpler function that agrees with the given function at all but one point. Use analytic and graphing methods to solve. So first thing we should always try to do is just plug in the -4. But if we do, we get 0 over 0. That means we need to do some more work. So I'm going to try factoring. That's always a good analytical method to use. So I have x plus 4 on the bottom. I know that having the x plus 4 on the bottom is what's causing me to get the 0 over 0. So that's going to help me with my factoring, because I know I want to get rid of that. So there's probably an x plus 4 in the numerator. That helps me with the factoring, because I know the first times the first has to be 2x squared, so that's got to be 2x. I know the last times the last has to give me 12, so this is going to have to be a 3. So when I check it, my outers are 8x, my inners are 3x. We have to get a positive 5x, so I need a positive on the 8, and we need a negative on the 3 to make it all work out. So now the x plus 4's cancel. That was the way the numerator factored. And so now I can go ahead and say, this is the function right here. This part, 2x minus 3, that's the function that agrees at all but one point. See, there's a hole in the graph at -4, but that doesn't matter. There's still going to be a limit. So to find the limit, we plug in -4. It's going to be 2 times -4 minus 3, and so the limit is going to be -11. I could have done that graphically too. I could have looked at my graphing calculator, and I could have seen that that is the y value that we are approaching. All right, for letter B, we try plugging in -3. -3 to the third is -27, plus 27 over -3 plus 3 is 0. Once again, we get 0 over 0. We have to do some more work. So we might want to go ahead and try factoring this. Here are the factoring formulas for cubics. You might want to write them up here in this spot. A to the third plus or minus b to the third is always going to be a plus b. Then it's going to be a squared minus or plus ab plus b squared. So what that means is this is going to be a value cubed, so we're going to have the cube root of this plus the cube root of this, if that's a plus. Actually, I want to put plus or minus here as well. Then for the next term, we do a squared, this value squared. If this is a plus, then this one's a minus, ab. This one is always a plus. So it's either going to go plus minus plus, or it's going to go minus plus plus. So looking down at our problem, if I want to factor this, I've got the limit as x approaches -3. I'm going to factor this, so I do the cube root, that sign, cube root. Then I'm going to have to square this, multiply these two because this is a and this is b, so it's going to be minus a times b, which is 3x, and then it's plus b squared. Here's b, so plus 9. All over x plus 3. So now we can cancel these two, and here would be the function that agrees at all but one point. So there is a hole in the graph at -3, but this is still going to be the function that we can now plug into to find the limit. So plugging this in, the limit's going to be negative 3 squared minus 3 times negative 3 plus 9. So that's 9 plus 9 plus 9. And so that's going to be 27 for the limit. Now let's say that you just have no idea how to factor that. Guys, every single problem you can think of can be done with synthetic division. If we're dividing this problem, I can use synthetic division to simplify this. I'm going to use synthetic division on this one. Let's say you're taking the quiz and you just don't know that formula. So I say, what's going to make the denominator equal 0? Well, it's negative 3. I put my coefficient of x to the third is 1, coefficient of x squared is 0, coefficient of x is 0, and then the last constant is 27. Synthetic division, I bring this down, I get 1, multiply, add, multiply, add, multiply, add. This is always the remainder. So what that means is that it factors evenly. Because I had x to the third to start with, this has to be right here, x squared minus 3x plus 9. See how that's the same thing we got when we factored it? So if you want to, you can use that synthetic division on problems like that. Regardless, either way we do it, we would now then plug in the negative 3 into here and we would still get the 27. Okay, so what about a problem like this, where we've got fractions? Well, if I try to plug in 0, I'm going to have negative 1/2 plus 1/2, that's 0 over 0. I have to do some more work. To simplify this, I'm going to multiply the numerator and the denominator by the least common denominator. So the least common denominator, I'm going to have to use the 2 and the x minus 2. I'm going to have to do that to the top. Here's the bottom. I also have to multiply that by 2 times x minus 2. The reason is because now I'm really just multiplying by 1, so I'm not changing the meaning of the problem. So I have to distribute. I got to multiply this times this. When I do that, I'm going to have 2 times x minus 2 over x minus 2. The x minus 2's would have canceled, and I just get 2. Plus, then I have to go to this one. I would end up with this over 2. 2's would cancel, so we would just end up with x minus 2. Whatever we're trying to simplify, like I'm trying to simplify the top, so I do multiply it all out. I'm not really trying to simplify the bottom, so I don't multiply it all out. I just want to leave it in factored form. If you do multiply it out, you're just going to have to factor it again. So now continuing, we've got 2 plus x minus 2. Well, that's just going to be x. So we get this. So now our x's cancel out. What's left on the top if everything cancels out? Not 0 either. 1. There's a 1 left there. So now our problem is the limit as x approaches 0 of 1 over 2 times x minus 2. My whole goal is to figure out what the answer is when I plug in 0 for x. These 3 dots just mean therefore. So I'm going to have 0 minus 2 is negative 2, so 2 times negative 2, it's going to be negative 1/4. We're going to wait for letter D for Friday. We'll review that one. Very similar, same process. Let's flip over on the back. These are 2 special trigonometric limits that we just have to know. If I plug in 0, the sign of 0 is 0. If I plug in 0 here, I get 0. So if I just try plugging this in, I get 0 over 0. That means I have to do more work. So what I'm going to have to do is, there's nothing I can do algebraically on that. So I'm going to have to go to my calculator and put in sine x divided by x. Whenever we have sine, cosine, or tangent, we do a zoom, trig. And here's the way the function looks. If I try just plugging this in, second trace of value when x equals 0, it gives me no answer. There's a hole in the graph right there. But remember, a limit is just a trend. What are we approaching? As we get closer and closer to x being 0 from both the left and the right-hand side, what is the y value we're approaching there? If you can't tell for sure, hit trace. What is that y value we're approaching? It's not 0.99. It's going to be the closest integer. It's going to be 1. Okay? The answer to this is going to be 1. Okay? On this one, I try substituting in. I have 1 minus 1, that's 0. I get 0 over 0 again. But this is a special trigonometric ratio. We're going to type this one in. So go to your calculator. Make sure you use parentheses around the numerator. Again, zoom trig. Here's the way the function looks. It is not oscillating around quickly so that there's no limit. Okay, that's fine. We should be able to tell what that limit is. If I try just substituting in 0, it tells me there's a hole in the graph there. But if I hit trace, I can see what it is that y is getting closer to. What's the integer that we're getting closest to right there? What is it, guys? 0, right? Okay. So this limit then is going to be 0. These are going to show up all the time, these two special trig limits. And the faster you know them, the easier some of the problems will be involving them. Here are some other helpful identities that we just have to know too. You should know tangent is sine over cosine. Cotangent is cosine over sine. Secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. Those are some identities that we may have to use within a problem. All right, so how do we use those formulas? Well, right here, I am trying to get this exactly. There's a 4 that I can't have to get that exact problem. So here's what I'm going to do. I'm going to factor a 1 out of the numerator, and I'm going to factor a 4 out of the denominator. And that's what I get. Those properties we talked about earlier tell us we're allowed to do that. We're allowed to factor out constants. So now we're going to have 1/4, and then what did we say this limit was back up here? What's the answer to that limit? 0, right? So it's 1/4 times 0. So that answer also would have to be 0. What about this one? What can I factor out in front here? What is it, guys? Take out a 4/3, right? So now when I take out the 4, I've got a sine t, took out the 3. So now we're going to think about this one. This is going to be 4/3 times whatever this answer is. So we look back up, right here it is. And that limit is always going to be 1. So 4/3 times 1 is going to be 4/3. We also could have done that by graphing, but it's easier just to do it that way. Okay, for number 3, we try to plug in 0. The cosine of 0 is going to be 1. The tangent of 0 is going to be 0. And then I plug in 0. So I get 0 over 0. I have to do some more work. I can't factor, but I can use my trig identities. I have cosine. What's another name for tangent? Sarah, what's another name for tangent? So I'm going to make this times sine over cosine, and then all over theta. Peter, do you know what's going to happen if I have a cosine here and a cosine here? They cancel out, don't they? So now I've just got the limit as theta approaches 0 of sine theta over theta. So be thinking about what is that limit. That's one that we just talked about, isn't it? Kyle, what's it going to be? What is the answer to this limit? This is 1. So that answer has to be 1. So we have to know our trig to be able to get through all of that. Okay, let's look at the next one. This one's a little tricky too. If I try to plug in, I'm going to get 0 over 0. Take my word for it, you will. Actually, in this case, you're going to get, the cosine of 0 is 1, so you get 1 over 0, but you still have to do some more work with this one too. So let's talk about how you would do that. Cosine is cosine times cosine. That's what cosine squared is. I have an x. Cotangent. So do you know what cotangent is in terms of sine and cosine? All right, so this is going to be cosine over sine. Well, I don't want to have this complex fraction here in the denominator. So I'm going to multiply by sine here, and I'm going to multiply by sine here. So that gets rid of that sign there, and now I don't have a complex. This is what I've got. I've got cosine times cosine times sine times x times cosine. What do we do now, guys? Cancel out the cosines. Now this is a little bit tricky. Here's what we have now. We have the limit as x approaches 0. I have a cosine x times a sine x over x. Look at the way I arranged that. See, it's not that the cosine is over x too, because if the cosine had been over x, it'd be x times x on the bottom, which is x squared, and it's not. So I either want to put the x under the cosine, or I want to put the x under the sine. Why is it best for me to put the x under the sine? Why is it, Michael? Yeah, this equals 1, doesn't it? I don't get something that's undefined. I get something that I can evaluate. So this limit here is 1. What's the cosine of 0? Think of the unit circle. Here's the unit circle. Cosine is just your x value. What is it? 1. So then what's this limit going to be? 1. Okay? Alright, so we're going to save this one for Friday as well. And so that's it. Make sure you do the homework. Good job.